In this video, we're going to figure out how much work the force of gravity does on a falling object. In this case, it's going to be a 1,485 kilogram Ferrari as it is dropped a distance of 40 meters. Now we're going to do this in two ways. We're going to use the relationship that says that the work done by gravity is going to equal the force acting on this car over the distance that this force acts, which is the definition of work. And we're also going to use the relationship that says that the work that the force of gravity does on this object equals the negative change in this object's potential energy. And what we're going to see is that it doesn't matter which way we find the work done on this car, whether we're using the definition of work, which says that work equals the force acting on the car over the distance that that force acts, or whether we use the relationship that says that the work done by the force of gravity equals the negative change in the potential energy of this car. We're going to see that they work out to be the exact same value. So let's begin to dissect this problem. So this car is going to fall through a distance of 40 meters, and we should start to define some points. Let's call this point down here y equal 0 meters, where we usually define the ground as 0 height. And we're going to define the point way up here as 40 meters. And in this case, our initial height is going to be 40 meters, and our final height is going to be 0 meters. And so one of the things that you should see is that this object is going to be falling in the downward direction. Our delta y is going to be a negative 40 meters. We're releasing this car from a height of 40 meters, but it's going to fall through a distance, a negative distance of 40 meters. You should also see that the force of gravity is the only force acting on this car, causing it to accelerate in the downward direction. Now we're going to ignore any dissipative forces like air resistance, and we're going to assume that the only force acting on this car is going to be the force of gravity. Now one of the things that you should see right away is that the force of gravity is acting on this car in the downward direction. It's causing this car to accelerate in the downward direction, and the displacement of this car is in the downward direction as well. So what you should remember is that the force of gravity does positive work on this car as it accelerates it in the downward direction. And that means that the force is going to increase the velocity of the car as it falls, which intuitively you already know from the study of dynamics. Now one last way to think about this. We often say that the force of gravity transfers energy to this car as it falls through this distance. So that's one other way I want you to think about work, especially as we use this definition of work. So to figure out the work that the force of gravity does on this car, it's going to equal the force times the distance through which this car is going to fall, or the distance that this force acts on this car. And in this case, which is going to equal negative mg, the force is acting in the downward direction, the weight force is acting in the downward direction, and we're going to multiply that by our delta y. In this case, delta y is going to be a negative number, because delta y, which is going to be y final minus y initial, is going to equal 0 meters, that's the final height of the car, minus the starting point, or the starting height, which is 40 meters. And in this case, 0 minus 40 will work out to be negative 40 meters. And we said the mass of the car was 1,485 kilograms, and then we're going to multiply that by 9.8 meters per second squared, and then we're going to multiply by the distance through which this object falls, and in this case is going to be a negative 40 meters. And one of the things that I hope you see is a negative times a negative is going to work out to be a positive number, and so the force is going to do positive work on this car as it accelerates this car. Now in this case, when I do 1,485 kilograms times 9.8 meters per second squared times 40, you should get a value of 5.8 times 10 to the 5th joules. So the force of gravity is going to transfer 5.8 times 10 to the 5th joules of energy to this car as it falls through a distance of 40 meters. Now the other way I said that we were going to calculate the work done by gravity on this car is by using the negative change in the potential energy of this car. Now this is going to equal minus, now you should recall that this equals minus the mass times the gravitational acceleration times the final height of this car minus the mass of the car times the gravitational acceleration of the car times the initial height of the car. Now in this case, the final potential energy of this car is going to be 0. This car can't fall any farther once it reaches the ground. And what you should see is that this works out to be a minus negative mgy initial, the initial height of the car. And again, this negative cancels out with this negative, and so you get a relationship for the work done by gravity using the change in the potential energy of the car equal to the mass of the car times the gravitational acceleration of the car times the initial height of the car. And if I were to plug in all of these values, what you would see is that I would get 1,485 kilograms times 9.8 meters per second squared times the initial height of the car, which was 40 meters, and that would work out to be exactly 5.8 times 10 to the 5th joules. So the energy the force of gravity transfers to this car as that force is applied over a distance of 40 meters is exactly equal to 5.8 times 10 to the 5th joules, which is exactly what we found using the definition of work. So both methods of finding the work that the force of gravity does on a falling object yields the same results.